Hello everybody and welcome to the next video of the course. This video is an introduction to the concept of a list inside of Python. So before jumping into the material, let me just say that any Intro to Programming course covers 4 foundational topics of programming. Those 4 foundational topics are if statements or conditionals, which we've already done, lists, which we're going to start now, and then the concepts of loop and function, which we'll do later. So what we're doing today is the second of 4 really big concepts in programming. Without these concepts, programming is basically useless, and modern programming cannot exist without them. So basically, if you're going to do programming for real, if you want to keep track of real data, right, you need a way to store lots of data, and a list is a way of doing that, creating a list of information. So the goals of this video are to introduce what a list is and then show you some basic things you can do with them. So this is an introduction, so we certainly aren't done with them at the end of this video, but you should be comfortable with the concept of a list and how you create one, and also be comfortable with some basic things that you can do with one. So the basic idea of a list you are already comfortable with because we've already covered strings. So a string is basically just a list of characters. So the string David McCune here, right? It's just a list of, in this case, 12 characters, D, A, V, I, D, etc. Okay? So we are already comfortable with the idea of a list of stuff, where that stuff is characters, because we've already covered strings. So a list will work basically the same way, where you have individual list items. They could be numbers, they could be strings themselves, whatever. But you've created a sequence or a list of list items, and they each have their own position inside the list, like position 0, position 6, etc. It's just that with a list, you can create a list of whatever you want. So in Python, you can make a list of anything. You can have a list of numbers, you can have a list of strings, you can have a list of lists, you can have lists of numbers and strings mixed together, whatever. There's no restriction on what can go inside of a list, basically. Whereas a string is basically only characters, right? A list of characters. Okay, so here are some examples of lists. So before you create one, you have to decide what you're going to call it. So I've named these 5 lists here, list 1 through list 5. You can call them whatever you want. You can call them X, you can call them my list, you can call them anything. Once you've decided on a name, to create it, you say equals, and you use square brackets. And then you just create the list inside the square brackets. So this list here consists of the numbers 1, 2, and 3. So each individual list item is separated by a comma. So this list has 3 entries, and those entries happen to be the numbers 1, 2, and 3. List 2 has 4 list items, or 4 entries, and they are strings. They're people's names. So the first entry is Lori, then Mary, then John, then Evelyn. And again, notice the entries are separated by commas. List 3 consists of numbers and names. So you can mix data types like that if you feel like it. So this consists of 5 entries, the number 5, 2, -1, Dave, Terry. List 4, notice, has 2 entries or 2 items. The first one occurs here, then comma, then the second one. But notice each individual list item is itself a list. So you can create a list whose list items are lists. You can create a list of lists if you want. So list 4 contains 2 list items, each of which is a list unto itself. Finally, list 5 here, notice has nothing in it. So you can create an empty list if you would like. And if you're wondering why you might do that, the answer is, well, you might not know what goes in there when you first make it. So when you first create this list 5, maybe your intention is that next a user of your program will come along and fill in the entries with exam scores or their names or whatever, who knows. So anyway, you might create an empty list because your intention is that somebody else will create it later for you, will fill it in for you. Okay, so the first thing to note about lists is that they act like strings in several ways, And the first way they act like strings is that each individual list item has a position inside the list. So in this list here, 1, 2, 3, item 1 is in the first position, which just like strings is actually position 0. So Python always starts counting at 0. So positions 1, 2, and 3 are actually positions 0, 1, and 2. So 3 here is in the third position, which is actually position 2. And the way you access an item of a list at a given position is with the same syntax you did with the string. So you give the name of the list, square braces, put a number inside of that. That's the position you care about right now. So list 1 at position 0 is the number 1. List 1 at position 1 is the number 2. List 1 at position 2 is 3. So the syntax is the same from strings. With strings, if you wanted to access an individual character inside of the string, you use this exact same square brace notation with the position inside of it. So similarly, with list 2, there are 4 entries: Lori, Mary, John, Evelyn. Lori is in position 0, Mary in position 1, John in position 2, Evelyn in position 3. So, for example, list 2, the name of the list, square brace 1 is the entry at position 1, which is Mary. List 2 at position 3 is the string Evelyn. Okay, list 3 contains 5 items, positions 0 through 4. The entry of list 3 at position 3 is the string Dave. The entry of list 3 at position 4 is Terry. The entry of list 3 at position 0 is the number 5. Finally, list 4 here contains 2 list items, right? This list and this list. So this first list item is at position 0. The second list item is at position 1. So list 4 at position 0 is a list, the list 1, 2, and list 4 at position 1 is also a list, the list 3, 4. Okay, so not only does that notation from strings carry over to lists, but some of the same kinds of operations that we had for strings will work with lists. And again, this makes sense because a string is basically a list itself, a list of characters. So for example, you can use the addition operation on lists, just like you could with strings. So if list 1 is whatever it is, and list 2 is whatever it is, list 1 plus list 2 is just the concatenation list. So you just take list 1 and then throw all of list 2's items in there. Okay, so list 1 plus list 2 is a new list containing all of list 1 and all of list 2, where list 2 comes at the end. So if you did list 2 plus list 1, you would just have 9 David followed by 157. Okay, if you have a list going and you want to just throw an additional item onto the end of it, you can use a function called the append function. We did not have this for strings, or we didn't cover it for strings. So just for example, if list 1 is 157, and suppose you want to throw a 9 into that, so you want to create like a comma 9 at the end, then list1 dot append 9 will do that. So if you write this command in Python, then after that command is over, list1 now has a 9 at the end of it. So append always throws an item onto the end of a list. The length function works just like it did with strings. So length of a list is just the number of elements in that list. So if list 1 is this, it consists of the number 19, -5, 5, 7, 8, 13, the list 1, 6, 7, and then 10. Okay, so let's just count. There are 1, 2, 3, 4, 5, 6, 7, 8 items inside of that list. Okay, so the positions of the list will run from 0 through 7. So anyway, the length function works for lists just like it did for strings. Just like with strings, you can do this little m:(n) notation to pick off a subpart of what you're looking at. So list 1 mn is the sublist of list 1 consisting of the elements of list 1 starting at position m or index m, whichever word you like, and not ending at position n, ending at position n minus 1. So this notation is inclusive on the left, but not inclusive on the right, just like it was for strings. So it's kind of obnoxious, I suppose, that it's not inclusive on both, but at least it's consistent with strings. So if list 1 equals this jumble of numbers, right, 5, 4, 8, etc., then list 1 starting at position 2, ending at position 4 is this list. 8, 2, 3, 8 is at position 2, 2 is at position 3, 3 is at position 4. You don't read off the 13 because you end 1 early. You don't go to position 5. You quit at position 4. Just like with strings, you can omit either m or n, and that will make sense. So list 1 colon n, it's the sublist of list 1 consisting of elements of list 1 starting at position 0 and ending at position n minus 1. If you put the n on the other side of the colon, now you're saying start at position n and go all the way to the end. Okay, so if you want like the first half of a list, right, or the last half of a list, you can just use a command like this. So if you want to go from the beginning to somewhere or go from somewhere to the end, you can use this truncated notation like here, just like for strings. You can delete elements of a list using the del, the del operator. So this command here, del, or I guess del, I don't know, delete, right, del. List 1 m will delete the element at index m from list 1. So for example, if list 1 is this, has 5 numbers inside of it, then the command del list 1 position 2 will delete the element at position 2 from list 1. And notice the number 3, that's at position 2. So notice, I'm not deleting the number 2 from the list, right? What's inside these square braces is always a position. So there is a 2 inside the list, but I'm not deleting that. I'm deleting the element from position 2. And the element at position 2 is 3. You can also delete an entire sublist if you want to. So del list mn will delete items at these indices, again inclusive on the left, not inclusive on the right. So it'll delete everything starting at position m all the way through position n minus 1. So for example, if list 1 is the same, right, the command del list 2, 5, it deletes items at indices 2, 3, and 4. Right, so 3 is at position 2, 1 is at position 3, 5 is at position 4. So this just shears off the right-hand side of that list, and you're left with just 4, 2. So you can delete things from lists if you feel like. Oh, and by the way, why might you care about deleting things from lists? There are lots of reasons, okay? But at some point, you guys are going to write a program that lets the user like enter all their homework scores. And what if you want to drop low homework scores, right? So what if the user gives you 15 scores and you want to drop 2 of them? Well, the easiest thing to do would just be to like find where those 2 lowest scores are and just delete them from the list. Okay, so there are all sorts of reasons why you might want to do these operations. So let me conclude with a warning here. As with strings, never try to access things that don't exist, So if list 1 is this list here with 4 numbers in it, well, there's position 0, position 1, position 2, position 3. There's no position 4. There's no position 5. There's no position -1, etc. So if you try doing things like this, list 1 at position 4, the program will get mad at you. Okay, it's not going to know what you want it to do. So it may or may not run, but if it does run, it will run improperly. It's not going to do what you want it to do because you're asking it to access something that doesn't exist. So as with strings, you have to be careful about that. You can only access elements of a list at positions that exist. Okay, so at the conclusion of this video, hopefully you're comfortable with how to create a list, and hopefully you're comfortable with some small manipulations of them, like adding them together or deleting items from a list, things like that.